imagine you've got a massive manufacturing factory, and the assembly line is it's moving entirely too slowly.
Which is a nightmare for production.
Oh, it's the worst.
Yeah.
But instead of hiring some outside architectural firm to come in and fix the problem, the factory itself just sits down, it analyzes its own physical bottlenecks, and independently drafts up the upgraded blueprints to build a faster, highly efficient version of itself.
That is quite the visual.
It is, but that scenario it's actually no longer science fiction. Welcome to episode 610 of AI Brief.
Yeah.
I'm Amin, and with me is Leah. And today we are tracking this massive thematic shift across the entire tech sector. We are witnessing artificial intelligence actively, aggressively breaking out of the digital cloud and rooting itself firmly into the physical realm.
It is getting real.
It's very real. We are unpacking OpenAI's brand new custom silicon, which is codenamed the Jalapeño chip. Plus, we're looking at a startup with just an incredible amount of conviction. They're training models to understand physical space and time rather than just text. And we will examine how Perplexity is putting hyper-capable agentic AI directly onto local physical hardware in your home or office.
I think to really understand all this, you have to realize that the central bottleneck for this entire industry is it's no longer just the mathematical architecture of the models themselves. I mean, we have largely figured out the math. The true ceiling has been the actual physical hardware those models are forced to run on.
Physical limitations.
Exactly. The power constraints, the thermal limits, even just the latency of data traveling over physical fiber optic cables. Every single update we are diving into today demonstrates an industry that is moving incredibly aggressively to solve that exact physical hardware bottleneck.
And that physical constraint brings us perfectly to our first major update today, starting with OpenAI taking matters into their own hands. So they have officially published the first benchmark results for their first ever in-house inference chip,
The Jalapeño.
which they built in this strategic partnership with Broadcom. And the benchmark statistics coming out of these internal tests they're just staggering. This chip is operating at 700 watts.
700 watts.
Right, which you have to compare that directly to Nvidia's flagship GPUs, which are currently sitting at 1200 watts. So not only is it drawing significantly less power, but the Jalapeño chip is actually answering up to 3.6 times faster.
Wow.
And performing 1.9 times more work per watt than Nvidia's top available options.
Those power efficiency metrics are truly the absolute most critical data points to focus on here, because delivering 1.9 times more work per watt fundamentally changes the underlying unit economics of generating artificial intelligence.
It changes everything about the cost structure.
Yeah, it does, because we have reached a point where data centers are hitting the absolute limits of regional power grid capacity. A 1200-watt chip does not just require massive amounts of electricity to run. It requires extreme physical cooling infrastructure just to prevent the server rack from literally melting.
Which is a terrifying thought for anyone running a data center.
It really is. So by dropping that power draw down to 700 watts while nearly doubling the output, a lab can process twice the amount of user requests without needing to go out and build an entirely new power substation just to feed the facility.
The performance numbers clearly solve a major physical bottleneck, but honestly, the actual engineering process behind Jalapeño is arguably the most fascinating part of this entire development. This represents a true closed-loop design ecosystem.
It's that factory analogy you brought up.
Exactly. OpenAI actually utilized its own upcoming Astra model, working alongside Codex, to help create the design for this very chip. They went from the initial design phase to a manufacturing-ready state in just 9 months.
9 months is incredibly fast for hardware design.
It is practically unheard of.
Yeah.
But the artificial intelligence is actively analyzing its own processing constraints and engineering the physical hardware required to run itself more efficiently.
And that closed-loop advantage is exactly why Hardware Vice President Richard Ho noted that they are not going to be selling the Jalapeño chip to the public or even licensing it to other companies.
Keeping it strictly in-house.
Strictly in-house.
Yeah.
OpenAI simply has too much internal need for inference compute to share this strategic advantage with the rest of the market. But it is vital to clarify here the distinction between inference and training.
Because they are two very different workloads.
Exactly. Jalapeño is an inference-specific chip, meaning it is designed to run the model and generate answers for users in real time. OpenAI will continue to rely heavily on Nvidia's hardware for the actual training of their massive frontier models.
So Nvidia is still very much in the picture.
Oh, absolutely. Looking at the deployment timeline, though, we will see these chips installed into OpenAI's data centers later this year. And they already have 2 subsequent generations currently in the design phase, with a massive production ramp-up scheduled through 2027.
It feels very similar to what Google did a while back.
It completely mirrors the strategic moat Google achieved years ago with their in-house tensor processing units. By owning the physical silicon, OpenAI secures significantly cheaper, faster tokens and creates this highly personalized, iterative design loop tailored specifically for every model they build in the future.
Solving the hardware power constraint is crucial, but it brings up a much deeper issue here. Because even if the models run perfectly on efficient silicon, traditional artificial intelligence is still just predicting text.
It's just guessing the next word.
Right. If AI is going to operate effectively in the actual physical world, it has to actually understand physical laws, not just linguistic patterns. And that brings us to Caltech Professor Anima Anandkumar and engineer Benedikt Jenik. They have just launched a new startup called Accelerated Understanding.
AU, for short.
Right. And their core mission is to train artificial intelligence to forecast how the physical world actually evolves, which is a massive departure from traditional models that merely predict which word comes next in a sentence.
The technical architecture here represents a fundamental, ground-up shift in how we even approach machine learning. Accelerated understanding is moving completely away from traditional transformer models.
Leaving transformers behind entirely.
Entirely. Instead, their system runs on what they categorize as neural operators. This is a physics-based architectural design that tracks and forecasts events continuously through 3-dimensional space and time.
And the scale of their initial testing it's difficult to fully comprehend, because in a single run, the accelerated understanding model processed 5 trillion data points.
5 trillion in one run.
In one run. That is roughly 5 million times the data volume that the top frontier models from Google and Anthropic are capable of hitting in a single run.
5 million times. That is an astronomical leap.
It is. And they are applying this massive compute power strictly toward highly complex enterprise solutions, specifically targeting the development of new chip materials, extreme weather forecasting, and advanced robotics.
Which all require that deep physics understanding.
Let's pause and actually unpack the mechanical difference between a traditional transformer and a neural operator, because it is vital to understanding this shift. A transformer, guessing the next pixel in an AI-generated video, it's just sophisticated pattern matching.
It's statistical probability.
Right. It's like guessing what a completed puzzle looks like based on the picture on the front of the box. But a neural operator is calculating the actual physics of how a robotic arm moves through 3-dimensional space, accounting for gravity, friction, and momentum.
It requires a structural understanding of reality itself.
Exactly. It is calculating the complex math of how the physical puzzle pieces actually interlock.
And that structural requirement is precisely why the founders walked away from immense guaranteed capital to build this themselves. Before launching Accelerated Understanding, Anandkumar and Jenik were offered top leadership positions and a 35% equity stake in Jeff Bezos' new venture, Prometheus.
Wait, they turned down a 35% stake from Bezos?
They walked away from it. Prometheus is chasing a very similar goal of physical world modeling and has since raised $12 billion in capital. Turning down a 35% stake in a venture backed by one of the wealthiest individuals on the planet to build this architecture entirely on your own is the ultimate conviction play.
That is an unbelievable amount of confidence in their own tech.
Walking away from that level of guaranteed capital indicates they view the current paradigm of text and video-based world models as fundamentally flawed for physical applications. They clearly believe their neural operator approach is the definitive mathematical answer to physical AI.
So we have massive enterprise physics models and closed-loop data center chips. Let's bring this push into the physical realm all the way down to what this means for your daily desktop computing power. Perplexity and Nvidia have just launched Portable Computer.
Portable Computer.
It is a completely on-device version of Perplexity's computer agent, designed to install with a single click on NVIDIA's DGX Spark desktop supercomputer.
Which is quite a machine.
It is. It currently retails for $4,699. Users are given a choice of local models during the setup process, so you can run either Quinn 3.827B or Perplexity's own PPLX 27B. Now, I have to challenge the premise here slightly.
Okay, let's hear it.
A $4,700 supercomputer is not exactly a casual desktop for the average user just typing up emails. Is this actually a paradigm shift for consumer computing, or is this just a highly capable toy built specifically for enterprise developers?
It is certainly priced for professionals and developers right now, but the underlying mechanics signal where the entire consumer market is heading. The immediate, non-negotiable benefit of running these 27 billion parameter models locally is absolute data privacy.
Which enterprises care deeply about.
Deeply. Your files, your financial documents, and your proprietary code never leave the physical machine. Furthermore, conducting this on-device work does not consume any of your Perplexity credits.
So it's essentially free to run once you own the hardware.
Once you have the hardware, yes. And to address the capability concern of running a smaller local model, the system features a highly intelligent cloud connector capability. If the local model encounters a complex task that exceeds its parameter count, it can actively ping over 15 different cloud models for assistance.
But it doesn't do that automatically, right?
Critically, this only happens with explicit user approval. It will ask before it sends anything out. And the financial context surrounding this hardware integration is equally important.
There's a lot of money moving around here.
There is. This release arrives just days after reports surfaced that Nvidia is in active talks to invest billions of dollars into Perplexity, participating in a new equity round that places Perplexity's valuation at over $30 billion.
That is a massive valuation jump, and it flips everything we have assumed for the last 3 years entirely on its head. We have spent all this time treating frontier cloud models as the absolute default starting point for any artificial intelligence task. By putting a hyper-capable 27 billion parameter agent directly onto local iron like the DGX Stark, the cloud is no longer the default.
It becomes the backup plan.
It is like having a genius-level assistant sitting in the room with you, handling 95% of your daily workflow with zero latency and perfect privacy. The frontier cloud models are being relegated to the corporate headquarters that your assistant only calls in a break glass in case of emergency situation when they're genuinely stumped by a highly specific problem.
The dynamic is completely reversing.
Yeah. So this entire shift toward autonomous agentic AI, whether it is running on your local machine or handling complex physical workflows, it is bleeding into every other major update happening across the industry today. I will open the floor for the rest of our news sweep.
We are seeing that autonomy play out immediately with OpenAI rolling out a new password access feature for ChatGPT work. This system acts as a highly secure password autofill, allowing the artificial intelligence to actually sign into your most used websites without exposing your actual login credentials to the broader foundational model.
Secure authentication has always been the missing key for true agent autonomy. A highly intelligent agent is completely useless if it gets permanently stuck at a login screen for your company portal.
And OpenAI claims the agent can now book appointments, fill out complex job applications, and execute personal errands across the web. They actually cited 19 specific examples of browser-based tasks it can handle autonomously from start to finish.
It's like handing over the keys to your digital life, but safely.
Safely being the operative word. And Anthropic is also removing friction from daily workflows with a brand new cross-tool memory feature for Claude. The model now automatically extracts and remembers key context from your previous conversations.
Which fundamentally solves the goldfish memory problem we've all experienced. It completely kills the friction of constantly reprompting the model with the exact same foundational context every single morning just to get it back up to speed on what you were working on.
It is such a time saver. If you mention a preferred writing style or outline your specific weekly organizational goals, Claude persists this memory across both the standard chat interface and their enterprise cowork platform. This means you maintain seamless context when jumping between different tools.
Are users able to manage what it remembers?
The feature is enabled by default, but users maintain full granular control. You can edit or disable these retained details simply by navigating to Settings and then Memory.
That level of control is great.
Meanwhile, Google is significantly accelerating its push into the enterprise sector by releasing highly customized industry-specific solutions. They are deploying ready-to-use agents, automated workflow tools, and third-party ecosystem integrations explicitly designed for legal and financial services professionals.
Going straight for the high-value sectors.
This targeted vertical approach puts Google in direct, fierce competition with both OpenAI and Anthropic for those highly lucrative, specialized enterprise contracts. And speaking of hardware positioning for this agentic future, Apple just introduced a new $899 Mac Mini powered by their new M6 chips.
The M6 chips are incredibly capable.
They are, and the specific phrasing Apple used in the announcement is worth heavily noting. They described it as a leading desktop for always-on agentic computing, claiming it is capable of handling these specific AI workloads up to 4 times faster than previous generations.
That messaging aligns perfectly with the trend we just analyzed with the Nvidia DGX Spark, just at a much more accessible consumer price point. Apple recognizes that robust, unified local memory and powerful desktop hardware are absolute requirements to run always-on agents effectively.
And finally, wrapping up the broader market news, Anthropic is actively preparing for an initial public offering. In their formal presentations to potential IPO investors, Anthropic leadership stated they foresee a total addressable market exceeding $30 trillion for artificial intelligence services.
$30 trillion.
To put that staggering economic number into perspective, that easily eclipses the $28.5 trillion total addressable market figure that SpaceX floated to its own investors back in May.
Taking all of these massive industry-shifting updates and multi-trillion-dollar valuations and pulling them down to your actual desk, let's look at the trending tools actively increasing productivity in day-to-day workflows right now. First on the list is AdKit. This is a tool designed specifically for marketing professionals to research their competitors, launch targeted advertising campaigns, and track performance metrics entirely through a single artificial intelligence interface.
It effectively consolidates an incredibly fragmented marketing software stack into one cohesive dashboard, saving teams from juggling 5 different platform subscriptions to execute one campaign.
Next, we have Skydive. This is a robust cloud platform specifically built for AI agents that automate tangible, real-world business tasks. If AdKit is the interface for marketing, Skydive is really the underlying digital infrastructure.
It provides the exact infrastructure layer that companies absolutely need to deploy and manage those autonomous enterprise workflows reliably at a massive scale.
Moving into creative workflows, there is SparkVid. This tool allows users to generate videos, meticulously direct the specific motion and camera angles within the frame, and execute complex video editing utilizing artificial intelligence.
The amount of manual, tedious labor this eliminates is massive. It will save independent creators and production teams countless hours in the post-production process alone.
We are also seeing a tool called Adapt, gaining significant traction. They position themselves with the phrase, "You're a company, you're agent." It is a single centralized agent that connects directly into every single software tool your specific team uses on a daily basis.
The primary value proposition of Adapt is the complete elimination of context switching. You no longer have to jump between 10 different applications or messaging boards just to gather holistic project updates.
Recapping our earlier deep dive, portable computer is currently trending heavily across the development community. This is Perplexity as agent running fully locally on NVIDIA's physical hardware.
It serves as a highly practical reminder of the massive security benefits of keeping sensitive local files completely disconnected from the public cloud.
We're also closely tracking Keenable. This is a specialized search API that allows isolated static AI agents to actively query and learn from the live, real-time web.
By integrating Keenable, you give a static, pre-trained agent a real-time pulse on global events and current data, preventing it from working with outdated or hallucinated information.
And ending on a highly engaging, lighter consumer note, ChatGPT has introduced a new stickers feature. You can now build custom sticker packs directly from your personal photos to send over iMessage.
It is a great, highly visible example of how these massive models are customizing our everyday digital communication in fun, highly personalized ways that anyone can easily use.
That brings us to a final thought to consider as we watch this industry completely reinvent itself. We are looking at a landscape where artificial intelligence is now utilizing its own internal logic to design faster, more power-efficient silicon chips in just 9 months. Simultaneously, we have entirely new models learning to forecast the continuous physical laws of our universe far better than traditional text-based architectures ever could.
The pieces are all coming together.
They really are. If the artificial intelligence is actively designing its own physical hardware and mathematically modeling its own physical reality, at what point does AI hardware and physical prediction become an entirely self-sustaining ecosystem?
That is quite the thing to think about.
That is the question we will leave you with today. If you want to stay ahead of the curve as this technology permanently breaks out of the cloud and into the physical world, make sure to follow the podcast and share this deep dive with a colleague who needs to hear it. See you in the next episode.
Thank you for listening, and have a great rest of your week.